welcome back to the channel. This is, we were talking about fuel and fuel injection, so this is to supplement that topic. I just had to get this A-level chemistry book. This is complete by GCP, complete revision and practice A-level chemistry, exampled AQA, and then alkynes of fuels, and then we've got here. This bit is the same as what I've just been talking about in fuel injection and exhaust emissions. So this is like a top-up video then. So it says incomplete combustion. What happens when there's not enough oxygen? Which is what he's just been talking about. If there's not enough oxygen around, hydrocarbons, i.e. petrol, combust incompletely or incompletely combust. This changes the product of the reaction and can lead to some nasty side effects like pollutants. So carbon monoxide, which is what he's just talking about. When a hydrocarbon, i.e. petrol, gasoline, undergoes incomplete combustion, you can get carbon monoxide gas instead of, or as well as carbon dioxide. For example, I'm not sure what, CH4G plus 1.5 O2G goes to COG, which is carbon monoxide, and 2H2OG, well, that's water, so that's carbon monoxide. I don't know what, not sure what the CH is, but 1.5 oxygen. And then you've got C8, carbon hydrocarbons. So I'm not sure what CH4 is. Sorry, I don't know what that CH4 is, but it's obviously petrol is a CH1, something CH other. Example 2 is C8H18, carbon 8, hydrogen 18, plus 10.5 oxygen, O2, gives you 4CO2, which is carbon dioxide, plus 4CO, which is carbon monoxide, plus 9 parts H2O. Yeah, so these are just examples anyway of hydrocarbons being burnt incomplete. This is bad news because carbon monoxide gas is poisonous to humans. Carbon monoxide molecules bind to the same sites as hemoglobin molecules in red blood cells as oxygen molecules, so oxygen can't be carried around the body, so you basically you suffocate then because you can't get oxygen. Asphyxia. Luckily, carbon monoxide can be removed from exhaust gases by catalytic converters on cars. Oh, so what they do, yeah, which is in the car book, you add oxygen to the carbon monoxide, and then you can react it back to carbon dioxide. That's quite good, isn't it? Carbon. So carbon particles can also be formed by an incomplete combustion. For example, carbon, hydrogen 4 plus O2 equals C. That's because carbon particles plus 2H2O. So it's thought to cause breathing problems. So this obviously is not cars, but it's just a general example of when it's got incomplete combustion. Oh yeah, so it is thought to cause breathing. Oh, so you can. So it is thought to cause breathing problems. You do sometimes see soot on spark plugs, don't you? It can also build up in engines, meaning they don't work properly. Right, let me put unburnt hydrocarbons and unburnt hydrocarbons and oxides of nitrogen can cause smog. So 1, engines, i.e. car engines, don't burn all of the fuel molecules. Some of them will come out as unburnt hydrocarbons, that's straight out of the exhaust. Oxides of nitrogen, nitrous oxide, are produced when the high pressure and temperature in a car engine cause the nitrogen and oxygen fuel atoms from the air to react together. Hydrocarbons and nitrogen oxides react in the presence of sunlight to form ground level ozone, or O3, which is a major component of smog. Ground level ozone irritates people's eyes aggravates respiratory system problems, and even causes lung damage. Ozone isn't nice stuff unless it is high up in the atmosphere as part of the ozone layer. Catalytic converters on cars remove unburnt hydrocarbons and oxides of nitrogen from the exhaust. Oh yeah. Oh yeah. So burning fossil fuels, including petrol, gasoline, contributes to global warming. Burning fossil fuels produce carbon dioxide. Carbon dioxide is a greenhouse gas. The greenhouse gases in our atmosphere are really good at absorbing infrared energy, heat. They emit some of the energy they absorb back towards the Earth, keeping it warm. This is called the greenhouse effect. Most scientists agree that by increasing the amount of carbon dioxide in our atmosphere, we are making the Earth warmer. This process is known as global warming, so that's not good. Oh yeah. Sorry. So, alkanes as fuel. So, alkanes are useful fuels. If you burn oxidized alkanes and other hydrocarbons with plenty of oxygen, you get carbon dioxide and waste. And water. It's a combustion reaction. Got out of focus. For example, here's the equation for the combustion of propane. So that was propane gas. Carbon 3H8 plus 5 oxygen 2 equals 3 carbon dioxide plus 4 parts H2O, which is water. This is complete combustion. The only products are water and carbon dioxide. There's also incomplete combustion, which is really bad. Alkynes make great fuels. Burning just a small amount releases a humongous amount of energy. Releases a humongous amount of energy. They're burnt in power stations, central heating systems, and of course to power car engines. They do have a downside though. Burning alkynes also produces lots of pollutants. Handily, that's where the rest of this topic's about, so that's all the other bits I covered. Incomplete combustion, burning fossil fuels, and then the unburnt hydrocarbons and oxides of nitrogen can cause smog. And if that's not bad enough, acid rain is caused by sulfur dioxide. But in terms of car emissions, the same process occurs when nitrogen oxides escape into the atmosphere. Nitric acid is produced. So some fossil fuels contain sulfur. When they are burnt, the sulfur reacts to form sulfur dioxide gas, SO2. Sulfur dioxide is a bit of a nasty beast. If it gets into the atmosphere, it dissolves in the moisture and is converted into sulfuric acid. This is what causes acid rain. So, as per here, unburnt hydrocarbons and oxides of nitrogen. Oxides of nitrogen are produced when high pressure and temperature in the car engine causes nitrogen and oxygen forms atoms from the air to react together. And this is saying acid rain, sulfur dioxide acid rain. The same process of sulfur dioxide acid rain occurs when nitrogen oxide escapes into the atmosphere, i.e., it dissolves into the moisture and is converted into nitric acid. So that's obviously not nice stuff as well. So acid rain destroys trees and vegetation as well as corroding buildings and statues. Acid rain destroys trees, vegetation as well as corroding buildings and statues and killing fish in lakes. Yeah, it's not very nice. In terms of sulfur dioxide, fortunately, so you got that's what the catalytic converters are doing then to reduce the to take out the nitrogen oxide. Fortunately, sulfur dioxide can be removed from power station flue gases before it gets into the atmosphere. Powdered calcium carbonate, limestone, or calcium oxide is mixed with water to make an alkaline slurry. Where the flue gas mixed with the alkaline slurry, the acidic sulfur dioxide gas reacts with the calcium components to form a hardless salt, calcium sulfide. See for more points, but that was just a little bit of an aside. We're talking about car engines. So anyway, thought that was quite interesting in terms of giving you a bit more idea about why, what exactly why is nitrogen oxide a pollutant? Because it forms nitric acid. It can form nitric acid in the atmosphere, and carbon monoxide, which is poisonous to humans because it said there, because it's asphyxiates you. You can't get oxygen in the blood. Oh right, so that's really interesting, isn't it? So if you breathe in carbon monoxide, you're going to die, and then the carbon dioxide part. So hopefully you found this interesting. It's just it's a good bit of extra chemistry, and then I'm trying to add this little thing. It's got that like the periodic table in the back. It's a really good book actually. Carbon, and hydrogen, hydrocarbons. Wow, that's really interesting. Wow. You've got hydrogen, hydrocarbons, hydrogen carbons. Really interesting, isn't it? So anyway, I'll see you in the next video. This one's been really, really interesting. Thanks for watching. Please like this video and subscribe to the channel. Thanks.